I want to take a look at number 6 here from section 15.1. It says you got a swimming pool that's 20 by 30 and it's filled with water. The depths are measured at 5-foot intervals, starting at one corner of the pool and ending at the other corner of the pool. And they're given here, estimate the volume of the pool. Now they don't say how, so I'm going to do it a couple different ways. And in fact, I'm probably going to ask you to come up with some more ways. So here we go. Let's take a look at that. I got the data here that they gave. So what I'm seeing here is a sort of looking at an oblique angle here. They've taken this thing, which is 20 feet going this way by 30 feet going this way, and subdividing it. In this direction, it looks like they chopped it into 4 equal pieces going like this. Right, because they've got to mark it. They're measuring at 0, at 5, at 10, 15, and 20. And likewise, going this way, they have it cut 6 ways. So at 0, 5, 10, 15, 20, 25, and 30. Okay. And then they're just saying at each one of these intersection points, how deep is it? So, for instance, they're along this edge here, which I'll think of as this front edge there. They're saying at this point you're down a depth of 2, at this you're down a depth of 2, at this you're down a depth of 2. Those are all supposed to be the same, and a depth of 2. So I've got 4 of them at 2, and then the next one drops down to 3, and then the next one drops down to 4, and that one's also at 4. So that edge kind of looks something like this. Now whether it's straight lines or maybe some curves in there, it's hard to say, but this is the only information I have. Right? Along that back edge, it's a depth of 4, it's a depth of 7, it's a depth of 10, a depth of 8, a depth of 8, and you've got this, that side looking something like that. Okay. Calculate the volume. Well, I'm going to do it a couple different ways. First way is sort of a broader picture. I'm going to just subdivide into 6 sub-rectangles here, right? So that I can use these midpoints to find the depth. So I'm going to find the area of each one of these pieces and then use the point in the middle to figure out how deep it is, and then multiply the area times that depth to get the volume. So here we go, method 1. My method 1, my delta A is going to be 10 by 10, so 10 feet by 10 feet. Okay, so 10 feet on this side by 10 feet on that side, which would be 100 square feet. And then I need to find the depth at each of these points. So those are given as this one, and 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 this one. So each one of those is going to be multiplied by 100 and then added up, or I can just add them up first and then multiply by 100 after. I've got 3 plus 3 plus 7 plus 5 plus 10 plus 8. Notice it doesn't really matter if I add them up going like this or add them up going like that, or taking some other order. Addition's commutative, so whatever order, it's not going to matter. So I'm going to add those all up, and then I'm going to multiply by 100 to get the approximate volume. Well, what does this add up to here? We've got 6, 13, 23, 31, 36. So 36 times 100 would be 3,600 square feet. Okay. So there's my first estimate of the volume. Now, maybe I can get a better estimate by actually looking at each one of these little rectangles and taking the area and then a depth for each one. So we'll subdivide a little bit closer this time. Delta A is going to be just 5 feet by 5 feet for 25 square foot, a little bit of area. And now I got to say, well, okay, how deep is it? Now for each one of these rectangles, I got to pick a point to measure the depth. Well, I'm going to choose, let's say, the upper left corner. So I'm going to use, for this for this corner right here, I'm going to use that upper left one up there. So that would be the 2. And then the next one over this corner on the upper left, that would be the 3. Okay. So actually, I'm never going to use this 8 because on this one over there, I'm using this corner, not that corner. So this 8 never gets used. Likewise, I won't use anything down along the bottom here because all these ones along this front edge, I'm using the upper left, so I'm not using that. So I'm going to just add up all of the things in, let's circle them with something here. I'm just going to add up all of those numbers, all of those depths, and multiply by 25. That is, each one's supposed to be multiplied by 25, and then add them up to get the volume, or add them up first and then multiply by 25. So how fast can you add? I need the sum of all those things. 2 plus 3 plus 4 plus, and so on. That one, that one, that one, that one, that one. Add them all the way up to plus 5, plus 6, plus 8. Right, those are all of those rows that I've got boxed in green there. And when you're all done, multiply that by 25, and this is going to be our approximate volume. And those numbers add up to, let's see how fast can you do it. I'm getting 134. So this is 134 times 25 for a grand total of 3,350. Did I say feet up here? This is, of course, cubic feet because we're doing volume. And likewise now, this is in cubic feet. This is feet cubed. Okay, so that's probably a better estimate of the volume than the original one. Now we could do another one by saying, well, rather than taking the upper lefts, why not take the upper rights, or why not take the lower lefts or the lower rights? I mean, yeah, any one of those is going to give you a different estimate of the volume. Right? You might try to figure out how to use all the information that's given here to get maybe an even better approximation of the volume. Anyway, there you go. There's 15.1, number 6.